This one. Yeah, let's speed up already. This is the content of the talk. I want to talk a little bit on the major developments we see nowadays on heavy-duty engines. It's more on the road transport than marine, I must say. Then I'll talk about fuel options and their consequences. There are basically two. You can have drop-ins or non-drop-ins, if you look at it in that way. And then what is the challenge actually, if you look at road transport. Come on. So, first, I always want to start a bit is what is an engine actually? We don't see that in this in these lecture series here, but if you look at an engine nowadays, it's the engine itself. In this case, a six-cylinder, but it's always accompanied by an after-treatment system. That's really important. It needs to work properly, otherwise you don't get your homologation. So whatever you do with your engine, be sure that the after-treatment system still can work with it, otherwise you cannot use it on road. In real life it looks like that. People from DAF might recognize this one. It's actually a DAF engine, one of the newest ones. And you see the thing on the left-hand side, that is the after-treatment system. So it's really, it has some kind of volume, so packaging is always an issue as well. So let's continue. Since I'm a teacher on engines, I want to explain what is a diesel engine. A lot of people think, okay, let's use this fuel or that fuel and just put it in the engine and it will run. Well, mostly it will not. It really depends on what kind of combustion concept you have. In this case, if it's a diesel engine, you directly inject your fuel in the engine near to the position where the piston is at the stop dead center. And then it needs to ignite rather quickly. Otherwise you will completely miss your combustion event and the phasing and the efficiency will drop drastically. Which means that the fuel has to have certain properties. It needs to ignite easily, right? Otherwise, it doesn't work. That's why you cannot put gasoline in the diesel engine. That's why you cannot put methane directly in the diesel engine. Does not work. So you need to be sure that whatever fuel you're going to develop, what's the platform you're going to use it on. Go on. So, what would its fuel appetite be for the regular diesel engine? Well, basically, of course, diesel or any biofuel that has come to regulations. That's a B10, a B30 maybe, or HVO. HVO is the first one that has really been accepted by the most OEMs to be used in the engine as is. All others, I don't know. What you cannot use is gasoline or any ethanol blend with gasoline or methanol or ammonia or hydrogen. Does not work in a diesel engine. So what to do? What's the current development I see in heavy duty markets? And that is really many OEMs are working on a hydrogen combustion engine. I've just heard people saying you should not use hydrogen in an internal combustion engine. But all of them are looking into it. I come later to why that is. But of course, you cannot use hydrogen in the diesel engine. It does not work. It has a rather high octane number, won't ignite properly, so your combustion will not happen. So you need to change the concept. And that's what's happening right now. Probably you need to change it to what we call a spark ignition engine. So you have a spark that ignites the mixture that you've put in early on in the compression phase. That means that your fuel, because you already put it in way before your piston is at top dead center, it needs to be hard to ignite. Hence we cannot use diesels or HVO or whatever you might think of in that range of products. You must use gasoline, E85, E15, E10, whatever you have. Methanol you can use, ammonia you can use, hydrogen you can use, if you have a spark ignition engine. So that is what's happening right now. They're really looking into that, and we're also part of that project. The major question is, why do they do that? And that's basically because of the EU directives. The EU directives state rather firmly that by by 2030, 30% reduction in CO2 needs to be accomplished. Of course, you can say, okay, yeah, let's use biofuels. Why not? If you have 90% reduction in your well-to-wheel reductions, that is a viable option, you would think. But the problem is that the EU currently states that it needs to be the tailpipe emissions. So whatever biofuel you put in, as long as it contains a C atom, is going to count. It's not counting as a reduction in CO2. Hence, the attention for hydrogen. Hydrogen, if you combust it, does not produce any CO2 in the exhaust. Hence, it counts as a zero-emission vehicle. Hence, it works for your portfolio if you're an OEM. And that's the biggest reason I think they're looking into hydrogen. Although maybe it's not maybe the most viable option you should take. But this is the regulations that come into place. So there's no choice. Well, if you then look back, what are fuel options? If you want to look at broader view on a well-to-wheel analysis, well, you can have two roads. You can go drop-in. That's by far the easiest way. You don't need to change the concept because 99% of heavy-duty engines are diesel engines, so you can just put it in by definition because it is a drop-in. It works immediately, and you get an immediate reduction in CO2 of your complete fleet. So that's a very viable option. What are possible options, possible problems you might foresee in the near future is that when Euro 7 comes into play, it might be so restrictive, and that's the emission levels on NOx and soot, that it might be very challenging for any internal combustion engine. And that's maybe a thing we need to keep in mind. Examples of drop-ins are FAME, HVO, and HPO. HPO is currently being studied also at our institute, and it performs really well, so you could use that as a drop-in. So no change needed in the engine concept. Well, if you then go for non-drop-ins, well, you can have a non-drop-in that is diesel-like with respect to its combustion properties. Talking about basically, stuff like DME or OME. They are really fuels that have combustion properties much alike diesel, so you can use it in a diesel concept, but modifications will be needed because these fuels are not compatible with the current fuel injection equipment. You really need to change it. So you need some changes, but again, it will give you, if it's a renewable DME or an eDME or OME, it will give you immediate reductions in CO2 for all heavy-duty engines that are around nowadays. If you then go for non-drop-in, then you come to the gasoline-like fuels. Thinking about methanol, hydrogen, ethanol, ammonia, for instance, this does not work in a diesel engine. You really have to change the concept. You have to switch to probably either a spark ignition engine type, that's what's depicted over there, or, and that's what you see in marine industry, dual fuel engines. You could use a gasoline-like fuel in your intake and then have a little bit of diesel-like fuel injected directly in near the top that center to ignite the gasoline fuels. There is, of course, you need to develop a complete new engine, at least for the heavy-duty market. It's not really mainstream, I would say. In the marine industry, they do exist. There are not so many of them, of course, these engines. You can make them really fit for your purpose. With respect to the Euro 7 emissions, it will still be very challenging. But probably we don't need a diesel particulate filter. These pre-mixed type of combustions, they do not produce much soot. And especially if you have fuels like methanol and ethanol with very few CC bonds, soot production is probably not a big issue. So you could simplify your after-treatment systems a bit. Well, what is now the challenge? And come to the end, I think I'm well in time. That's nice. Well, basically, that the biggest challenge is that current EU directives, they give no incentive whatsoever for OEMs in the heavy-duty transport to develop any engine on biofuels. They simply do not count. It doesn't help. That's a big issue. That actually would suggest it's best to make a drop-in, because then you can use existing technology and you don't need to rely on the OEMs to develop a new engine. But having said that, the new Euro 7 emission legislation might be a big hurdle to take because of the emission levels of NOx and soot that need to be gained. But that's the word is still out. It's still not decided. They're negotiating a lot to see if that is really going to happen. Well, the most questions I get from either the OEMs or from fuel companies, not like Shell, but the ones that hand out the fuels to the customers. How do you say that? Say, okay, what fuel should we invest on? What should we take? What's it going to be? Well, I don't know. We don't know. But I think, looking to this system, we should make a clear choice. Not give many options. That will be very difficult for the filling stations to make sure that you can get them. What's also very important is that they are available across Europe. We cannot have a solution for the Netherlands alone. That does not work. It needs to be across Europe that we have these fuels. Otherwise, it will be a no-go. And what's also very important, I learned that from my colleagues at DAF, standards. We need standards for the fuels that are not there yet. As long as they are not there, and you bring a fuel on the market, the OEM will say, okay, does it follow the standard? If not, okay, you cannot use it in our engine. It's liability issues. What the good news is, and that's what I learned a lot when working with these companies, is that they can make a good engine for any fuel. We just have to decide which fuels they are going to be. If you stick to the drop-ins, the drop-in diesel-like fuels, then the engine is already very good. And there is still some room left for optimization. But what they cannot do is make a good engine for all different fuels at the same time. That does not work. So in my opinion, we need to make some clear choices, but we cannot do that as the Netherlands on its own. It needs to be Europe at least, or worldwide preferably. But they can do it. That's what and as an example, this is a study from a Swiss company. They've just made a DME engine. In a very short time, it ran perfectly without major problems. Only in the end, when they want to do a real daily operation test, they were held back by the company Bosch. They just said, oh, you have this special pump in your vehicle. You cannot use it on road. So this last step, they couldn't make. But they were very happy with the results. Very good efficiencies, very good emission levels, and no running problems whatsoever. So we can do it. The OEMs can do it. It's only the thing is that we need to make choices and make them not as wide as we can.